Hello everyone, I'd like to welcome you to this video. And this video we're going to talk about the conventional machines for manufacturing that we use, specifically the lathe, the milling, and the CNC machine as well. And of course, if you are already familiarized with any of the terminology that I'm going to explain in this video, you should stick a little at least for you to make sure you understand all the parts of these conventional machines, especially if you only learned the parts or how the machines are comprised in Spanish. Believe me, this video will help you to get through in English so you can improve your skills as well, not only for manufacturing but also for speaking with other people, and so your limits or boundaries will get expanded even better. And if you haven't used any of the machines that I'm explaining in this video, you should also stick especially or specifically if you would like to get involved into this wonderful world, which is the manufacturing processes as well as design. Alright, furthermore, let's begin with this video. Alright, so let's begin talking about one of the basic machines, which is the lathe machine. This machine is one of the basic ones because we use it most of the time to manufacture circular shapes or at least cylindrical ones due to the piece rotates. Therefore, in order to use this machine, it's very important to know its parts in English as well. So we're gonna go breaking different sections so that you can understand better what are the names of each part of the machine, how it is comprised as well. So as we can see right now here on the presentation, we know we have the headstock, which is where this red pointer is right now. So the headstock is where all the mechanism and the controls, the panel controlling is sited. You can adjust, of course, the rotational speeds, which are better known as the RPMs. You can also stop the machine in case of any emergency, and many more features that you can add to this kind of machine. We're gonna go one step at a time, just explain and breaking through for you to better understand what we're talking about. Also, we have the chuck. This part, it works or it's used to hold the part or the material that it's going to be manufactured and it's going to be cut. So if you want to manufacture, let's suppose, glass or a cup, let's say like that, made of steel, for example, so you may have the steel in a square, or probably you may have it rounded, and the chuck is gonna be comprised of 3 different teeth or more, which are gonna just compress and it's gonna hold the part together. Alright, that's what the chuck is for. And we have the tailstock, which is the other part in which whenever you have the material, a very long material, of course, the longer the material is, the greater the momentum it creates, and therefore the bending forces is gonna be greater as far as you are from the chuck. So you want another part to be holding the end part, which is like you have the first part in here on the chuck, and so the tailstock is gonna hold in a pin. Let's call it like that right now. It's a pin which works to hold the ended part of the material. So the material will stay uniform in all situations during the manufacturing process. And we have also the tray in here and the 2 legs. So let's go and explain with a little more of detail how each part it works. All right. Okay. So let's go first with the headstock. On the headstock we have what is called the feed box. As you can see here, the feed box is comprised of the RPM adjuster, which is a little round roulette here, where you can choose what RPM is suitable for your piece to manufacture. Of course, you want to generate the less friction as possible. even though the cutting tool is made of carbide, which is a very, very hard material that can enhance or support the the heating parts. So that's very important. We do have also an emergency stop, which is this red button over here. Whenever you see anything it's out of hand or it seems to be getting out of control, you just have to press it once and the whole machine is gonna stop by itself. We do also have the green button here, which is the starting. It's just to start the machine. Okay, the power button. And we also have this white button, which works for the oil. So whenever you need to use some oil, it's gonna start sprinkling into the material to avoid abrasive processes and to avoid breaking the cutting tools as well. Okay, so you wanna create less friction sometimes, depending the RPM being used, and many other situations and procedures. We do also have here what is this last part here, as you can see, these three handles and the last valve. It's called a specific thread. Now, why do we call it specific thread? As you can see here, well, it's not very visual, but in this part where I'm pointing right now with the laser point, sorry, here it comes different measurements, different RPMs, different features that you can adjust the machine to create a specific thread. What's a thread? The thread is what we call it, or you must know it as the screws, for example. Whenever you use a screw, the little part, the little round the coil that seems to be surrounding the part of the screw, that's called the thread. Is the little path that follows in order to rotate and get adjusted into the other part. Okay, so this is the main part for the headstock and its controllers. Alright, so let's continue talking about the second section, which is all the middle part. We're having here the chuck, the bed, the fitting rod, and the lead screw. Alright, let's break it through in different explanations so you can understand better for what is the main functionality for each part. For example, the chuck. Like I said before, the chuck is gonna be comprised of 3 or 4 teeth that are gonna just decrease its angle, alright? So you need a chuck key in order to start compressing or expanding its diameter. So these little teeth, well, it's not that very little, but these teeth, let's call it like that, they're gonna compress in order to decrease its diameter and hold the piece very tight. So let's suppose I'm holding here. This is the part that I'm gonna use for manufacturing. So the chuck is gonna decrease and hold it very, very tight. Of course, we want it to hold it very tight because the lathe machine, or the main functionality for the lathe machine, is to start rotating the part to high RPMs. And we all know physics at this point, of course. So what happens if you start rotating a part into incredible or ridiculous RPMs velocities? Of course, the whole part can just snap off the machine and fly off, and that can cause an accident that we don't want to happen. All right. Therefore, the chuck must be made of a very, very brittle material and very hard, which is most of the time iron. All right. After that, we come with the bed. The bed is not the part that's gonna hold the material, right? Like I said before, that's the job of the chuck. The bed it's only used for us to move the carriage, the saddle as well, which comprises of the cutting material. So, like I said, let's suppose I'm holding here my piece. I have already the chuck holding the ending part of my material, and let's suppose I don't want to start manufacturing from here, but I would like to start manufacturing from this point. So that's the bed, all right. That's gonna allow me to move the carriage. However, how am I gonna be able to move the whole carriage? Yeah, I know I have the tracks already, but what is gonna allow me to move this carriage? Well, we have something called the feed rod. Apologies for this part. I don't know why I was supposed to change it as well, but I don't know why it's still showing up as feeding. But it's feed rod. All right. The feed road is going to work for me to start moving the carriage to the specific point where I would like to start manufacturing, or I would like to begin the manufacturing process. And so we also have the other part, which is called the lead screw. Lead screw, it is used for a difference. The lead screw, in other words, is gonna still allow me to move the carriage but into the right axis. For example, we all know this position, right? We know we have our X position, our Y position with the thumb, of course, and our middle finger is gonna be pointing towards K or Z position, all right, axis. Let's call it like that. So we have our index finger pointing to our X axis, our thumb is gonna be pointing to the Y axis, and the middle finger is going to be pointing to the Z or K axis. So, according to this, if you want the carriage to start moving, let's suppose to the right, let's suppose this little part here, this eraser that I'm holding is my carriage. Okay, so let's suppose I'm holding my carriage right now, but I want it to move to the X direction. I don't want my carriage to all of a sudden change of angle and start moving like this. It's still being on the X direction? Not really. X direction is like this. Alright? This is the X axis. And what happens if it's not completely straight? If it's not completely like in a train, alright? Let's suppose the rail is just different and it changes of direction. Okay, we're having some issues here with the angles. So if that happens, my carriage will start turning of angle and will start moving towards X, but also to the Y direction, and I don't want that. All right. Therefore, we have the lead screw. So the lead screw is like that little track, that is going to allow the carriage to move to the correct axis without moving or switching directions in angles and anything like that. So that's what we call also the degrees of freedom. We're going to constrain all of that. So that's what the lead screw it is used for, as you can see here. All right, let's move on forward. Alright, so continuing with the explanation, here you can appreciate better the view of the bed as well as the tray. The tray is like a small container which is gonna have the shape of a bowl so that all the chips that's gonna fall out from the part after being cut, they're gonna be remain on the tray so that you avoid just sending all this waste or the material cut into different directions, into different parts, and you can also avoid an accident. What if someone would be walking by the machine and he or she all of a sudden step on a piece of chip? So they can just slip off and they can have it or cause another accident. Therefore, we want to constrain all the chips or all the material being cut into a specific part or tray. That's the main function of it. And as you can see here, the bed, like I said before, it's like a trail, alright? It's like a railroad, after all. So it's just a position where the whole bed and the carriage is gonna be holded, and of course it can move freely over those directions and changing and whatever positions you needed. You can just, of course, arrange it to your liking. And at the same time, working with this machine, it will be very comfortable for you, as well for achieving difficult geometries as well. All right. Being said that, we are left with a tailstock. The tailstock, like I said before, is the end part of the machine, which is going to be holding the other part of the material. So let's continue using the same example with this with my pencil in here. Well, it's not really a pencil, but it's a mechanical one. So I have my mechanical pencil, and like I said, my left hand here is going to simulate the chuck. Okay, so the chuck is holding one part of the machine. But as you can see, or like I said before, the longer the material it is and the force you want to apply in the further direction from the center or from the part which is being held is going to create a greater momentum. Which means, let's suppose I apply pressure in here, so the whole my pen or pencil here, it's going to start bending off. Alright, which means it's gonna start, um, it's gonna stretch the material inside, and it can cause even breaking parts. Now imagine this part or this material rotates at high RPMs, and all of a sudden you apply the force due to the RPM and the abrasive process that it's suffering right now. I mean, an increasing of heat. It's gonna cause the whole material to snap off, and you can just break it off. All right, you don't want that. Therefore, we have the tailstock. The tailstock, it works so we can hold the other part of the material at this point, so it's going to be even at the moment of rotating, and so that being constrained into the two ends, it's going to call for you to start applying different pressures, and it's not going to happen anything bad because the whole part is going to be fully constrained. It's not going to be movable. That's what I mean with constraint. All right. Now let's break out the parts of the tailstock. We have something called the ram clamp, which is this part. The ram clamp is, of course, the part that is gonna hold the dead center. All right, we call it dead center. The little point that is gonna be holding the other part or the other end of the material. So the ram is gonna be holding the center. At the same time, the ram is gonna be clamped inside this part of the machine, as you can see on the screen. And this is a lock. Alright, that's what we mean with ram clamp. Now, tailstock lock. The tailstock lock, it depends on what distance you want to hold the part. Not all the materials is going to measure the same, alright? Some are going to be larger, some are going to be shorter, and it depends a lot on the thickness of the material as well. So who knows? What if it's shallow than the inside? So the tailstock is not going to work, alright? It's not going to work the same. So therefore, you want to know at what distance you're holding. What if I'm holding the piece from here and the tailstock is supposed to be holding at this distance? You see how much difference there is? And it's going to happen the same thing, that you're going to start applying a lot of stress, a lot of work into different sections. It's going to break or snap off. And you don't want that to happen. Therefore, you have to adjust the tailstock to touch the other part of your material, so your material is fully constrained. Alright, or is still, let's call it like that. And so you don't want the piece or the centripetal forces or whatever is happening as well, you don't want that to push the tailstock away. Therefore, we have a tailstock lock. So no matter what forces the material is applying to the tailstock is going to remain still during the whole manufacturing process. Excuse me. All right. So that's the main function of the tailstock as well. Now, the tailstock lock. Sorry. Now we have also the hand wheel, which is going to be how far I would like to start pushing the slide. All right. The hand wheel. How far I want to push the slide, which is going to be holding the dead center, so I can hold the other end of the material. Okay, so you want to move the tailstock through the rails. Yes, of course you want it, but you also want to increase the length of the little ram that is going to be holding the dead center, and that's you do it with the hand wheel. So you just start rotating the hand wheel, and so the whole tailstock is going to start pushing that little part, so you can reach the other end of the material as well. Alright, so that's how it works pretty much. That's the main function of the tailstock. Now, let's move to the part of the carriage. The carriage, let's say these parts are the most difficult to understand and learn, especially because on the main part we have what is the tool post. On the tool post, you can adjust it. You use it. To adjust the cutting tool. All right, you put there the cutting tool, the carbide one, and the tool post is gonna help you to just fix it. We have also the compound rest. The compound rest in here, as you can see, it's the part in which is gonna adjust the angles of the cutting tool. So let's suppose this is as well my cutting tool. So let's suppose my cutting tool is at 90 degrees angle. Alright, let's suppose this is my part, my index finger is my part, and this is the cutting tool. So if I adjust the compound rest, of course, it's gonna start moving the material like that, so I can achieve different angles through the whole material, or just manufacturing at perpendicular directions. All right, whatever it fits you, whatever you feel more comfortable, that's why you change the angle. We also have the saddle, which is this little part over here, pointing. So the saddle works to hold the whole tool post at the compound rest. Okay, and it's gonna help you to start moving into different axes as well. So like I said, with the rule of our three fingers, the thumb, the index, and the middle finger, you want to move it now to the Y direction. All right. So in this case, you want to move it to the Y, which is my thumb direction, or the direction that is pointing my thumb. And so you use the saddle in this case to start moving off. Then we have the hand wheeling here, which is going to work as well to start moving the whole carriage through the railroads or through the table. All right, like I said before, this is my material, and let's suppose the whole carriage is already sighted here. But I don't want to start manufacturing at this point. I want to start manufacturing here. Okay, so if I move the hand wheel, I will be able to move the whole carriage through different lengths. All right, through different lengths. Sorry, yeah. Okay, and so we have as well the cross-line hand wheel, which is little cross-line hand wheel, is what will adjust the it will adjust the precision of the cutting tool, and of course to move it into the Y direction, okay, or to the direction that is going to be cutting. And finally, we have the apron. The apron is the whole mechanism which comprises the carriage. All right, what it allows to move it through the lead screw and of course the feather rod as well. So the whole apron contains all those mechanisms that is going to allow the whole carriage to move on the table through the lead screw and everything, and also in the Y direction. All right, that's simple as that. Apron is not a rocket science, as many people think. All right, so that would be pretty much the end of the lathe machine. Another conventional machine that we have is called milling machine. We're gonna start talking as well a little more about it. Hmm, sorry about that. Speaking a lot made me feel thirst. Alright, I just wanted to make a quick pause here at this point because before I start explaining the milling machine, all the parts and everything, I just want to highlight the most important part of the milling machine, and is that this machine is not literally used or very much used to achieve very complex parts. I mean, you can rework the surface of a material, or you can decrease it and change the shape whatever you want, whatever you're feeling like. However, you can also use it to drill different sizes, of course, using different features that we're going to explain in a moment. But before I start explaining all the parts and what are they used for, I just wanted to highlight why this machine was invented for. All right. However, if you want to achieve very complex shapes, then we're going to use a different one called the CNC, and we're moving forward to the following machine as well. Okay. Furthermore, let's continue with the video. Alright, so let's continue with these video and explanations for the milling machine. Like I said before or earlier, the milling machine is very used for drilling and to achieve different forms but not very complex shapes. And so this machine it comprises of the motor. It's not the same as the engine, alright? This is called the motor. It's not the same. The engine are for cars. The motor, it's any device used to achieve any work into a machine. Alright? So on the top we have the motor, we have the head or drive. Here, this is the white part or the white shape. We still have the red button here on the yellow panel. This is used or still being used in anything that it doesn't seem well. Then you can stop the machine immediately. Now we continue here on the work table. The work table is going to handle all the part, this little part in here, which is called as well the saddle, in order to move the carriage, which is going to hold the fixture. or the jig as well. You can call it jig as well, in order to proceed with the manufacturing process. And we have the column, which is the back side. I know it doesn't appreciate very well here, but don't worry, I'm going to show you a picture where you can see it better. And the base of the whole machine. Pretty much these are all the items and features that this machine has. But let's go ahead and break it through with more detail. Alright, so let's review the top part of the milling machine, where here the we have here a little handle, which is used for, it's called the gear selector, and this is used to choose the right speed of for the milling machine. You want probably to start slow and then start increasing gradually the speed, so you can achieve a better surface or better work on the material. Like I said before, these red buttons still named the emergency stop. Then we're gonna have the handle. This handle is gonna bring the spindle down, and which is gonna hold the cutting tool, and so you can go ahead and drill all the way through the material. This green side that is holding the top part or the head of the machine is called a turret. So pretty much it's gonna be holding all this part. That's why it's called turret. And so I know it doesn't appreciate very well in here, but the part where it's the spindle is called the spindle because it's one axis that goes from here all the way inside through the turret and goes all the way through the head up to this part, which is also called the head. Alright, and so we have these. So the spindle is gonna go all the way through the head, well, from the bottom through the head, and from the bottom all the way inside the machine through the head, and the spindle pretty much is holding, or is gonna hold the cutting tool as well, and that's why it increases the RPM here. So the gear selector is gonna be adapted in order to rotate the spindle at certain speed or certain RPM. And so the quill works because the quill is used to hold the cutting tool, and at the moment you just pull the handle, pretty much the quill, it's gonna go, let me use this example again. So let's suppose this pen is my quill. So at the moment I press or I start pulling the handle down, the quill is gonna extend within the cutting tool so you can reach your material or the surface in order to start cutting and make your procedures. Alright, so the feed hand wheel, which is this part over here, it's pretty much used for bringing the quill down or up, depending. You're going to be able to adjust the quill, and so at the moment you pull the lever, you're going to have more space to go down. So let's suppose that due to my quill, the machine is holding here, due to the feed hand wheel, it's adjusted already at once at a specific height. So the machine is holding my quill up this part. So at the moment I bring the handle, it's just gonna go down all the way that is possible, right, until the handle reaches the bottom part. However, if I start adjusting the feed wheel into a different, or the quill wheel it is also known, into different adjustments, then the quill is gonna start decreasing, and so my machine is gonna have a lot more space or tolerance for holding the tool and bring it down. So at the moment I just pull the handle once more, it's gonna go even deeper into the part. That's why the feed wheel is very important as well. Alright, let's move forward to the other part of the milling machine. Here you can see the saddle. Like we learned, the saddle has the same functionality as the lathe. It's gonna move this little part which is called as well the carriage, or the fixture in this case. It's not more a carriage because he already has. I mean, all the machines have the same three directions, like we learned before with the right hand rule, but it's not gonna be like floating or on rails. It just has already a table, all right, where it's gonna be settled, and the whole table is moving pretty much as well within this part of the fixture. And the saddle is still working to move my fixture into the Y direction, which will be that way where I'm pointing right now, the laser. Okay, here we have the base. Of course, the base will be what is holding the whole machine, and the column. The column is a part that's holding pretty much the turret and the head part of the machine. Then we have the cross transverse handle. It's this little handle over here. This little handle is going to be used to move the saddle into the Y direction. So if we have, for example, this part holding on already on the fixture, and we're manufacturing our cutting tool is in here, then of course the cutting tool is not gonna go through the pen, right? But if we want to go through the pen, then we use the cross traverse hand table, and so we start moving into the Y, and now our cutting tool will be able to reach the part. That's what I mean that it's moving on the Y direction. Okay, remember your right hand rule every time that you get confused. Your thumb is always pointing to the X, your index finger is pointing to the Y, and your middle finger is pointing to the K direction or the Z. Alright, let's continue.
Alright, we're finally at the last stand of this video. We're gonna start talking about the CNC machine. Don't worry, it's not that hard. If you pay attention to during the video about the parts of the lathe and the milling machine, pretty much the CNC machine is a combination between these two. You're gonna see why. So just be patient. Of course, I'm gonna explain the best that I can on the CNC machine, but it's way much easier because the CNC machine it's gonna be automatic and not mechanical. I mean, like not manual. All right. So let's get started.
Alright, let's begin by explaining what does CNC stand for. CNC stands for Computer Numerical Controller, which means the whole machine is going to be controlled by a program, alright? It's going to be automatically. You don't have to put the hands except for changing or switching some tools, and of course putting your material inside and just constrain it very well, so the machine will start just doing the work itself. The most important thing, at least right now, that you must pay attention during the images, it's that as you can see here where I'm pointing, these doors are for safety. So whenever the machine is going to start, whenever the machine starts cutting off the material and starts creating the shape, of course inside of the machine is going to be a mess, and it could be dangerous. Like I said before, every chip or piece of material that just gets cut off, it's a very brittle material, so if it flies off the machine or anything, it can cause an accident. And of course, for safety procedures, that's illegal. And if you manufacture a machine that is dangerous for other people, of course, you can even go to jail. That's against the rules. All right. It of course depends also on the country, but at least I can say or talk to you about how Ontario in Canada the law and procedures are just applied. All right. So let's begin with the parts. So let's go through the machine to understand how it works. All right. So first of all, we have the control panel on the outer side of the machine. The control panel, as you can see here on the screen, it shows X, Y, and Z axis. That's because you have to use this panel in order to. It's not like you control the machine at the moment, but you must install the program or your program, which is gonna end manufacturing the whole part. The advantage of using the computer numerical controller machine is that you can achieve definitely very complex parts, and you're gonna see why. We have also the tool turret or the ATC, which stands for automatic tool changer. Yeah, for automatic tool changer. So what does automatic tool changer means here? As you can see, this tool turret, we call it as well because all these little pockets in here or openings can hold multiple tools. So whenever the machine needs to start, like, let's suppose it's gonna drill a hole. Okay, you have, for example, here the drill, but then it's gonna cut. So you have a milling tool in here, and then you're you're going to start decreasing the thickness of the material because you need to achieve a slight slope on the material. And let's suppose like you have your material like that, but all of a sudden you want to achieve a slight slope like this. So you're going to start milling to start cutting off some parts on the same material. That's the beauty of tool turret or the ATC. As you can see here, this tailstock is nothing new about it. We've seen it on the lathe machine previously. The lathe stock, remember, it will hold the dead center, which is the little point thing here inside of the ram. And remember, this will be the ram lock as well as the tailstock lock. Some of them have it. The difference of these is that, as you can see, there's no wheel to slide off the ram. And the reason is because the whole machine does it automatically. So you only need to make sure your piece, if it's going to be very long, of course, you're going to need the tailstock to hold the end part of the material so you can continue manufacturing at least precisely. And of course, we have a spindle in here. The spindler is going to be helpful for the chuck. So the spindler is going to hold the chuck and it's going to help it to rotate. So let's suppose all of a sudden, like, okay, you finish the surface or the upper surface of the material, and then you need to rotate it to start cutting now on the underneath. So that's what spindle does. Alright, it's going to help it. And we also have a servo motor. A servo motor, it will help the spindle to rotate. Alright, so this is the little motor. Remember, engine is not the same as motor. The engine will work with electricity, and the motor will work with the fluid, which is hydraulic. Alright, so here the servo motor is powered with electricity, and so it helps the spindle to just rotate, and so the spindle will rotate the material. See? That's how it works pretty much. We also have the chuck. The chuck will be holding on the spindle, and so remember, we just a quick review, of course, from the lathe machine. The chuck works to hold one end of the material very, very tight. As you can see here, the chuck has 3 teeth on it. There are some that have like 4, others that have 6. Of course, it depends on the diameter and the brittleness of the material as well, and also the hardness. So in this case, with 3 it's more than enough, of course, in some procedures, but you will have to pay attention. What material are you having? What geometry do you want to achieve at the end? And just like slight notes, I'm just gonna make a quick note in here. Many people believe that the same chuck works for all the materials, but some unfortunately applies more pressure on the end of the material that ends up hammering your your material. What does hammer mean? It means that it damages your material. Alright? And we do also have an axis motor. The axis motor, as you can see here, is as well controlled automatically by the machine. This is what controls if the path of the cutting tool is going to be either straight or it's going to start changing to circular and it's going to start moving in different directions. That's what the axis motor is used for. That's why it's called axis, right? Because it doesn't necessarily need to follow just the x-axis or the y-axis or the k, but you can start following different angles as well. Alright, you can switch it all of a sudden. Alright. We do also have the hydraulic oil tank and the lubrication oil tank. So the machines must have these reservoirs, of course, for the oil and coolant as well. The reason is because depending on the material and the brittleness, there will be also different abrasive levels. Some may get hotter, others may get not that very hot. So whenever it's really hot, you need to keep the temperature steady. Otherwise, your material can start melting off, and whenever it's finished, it will just start smelling awful. But besides the side of the smell, the most important part is that your material it's gonna end up very damaged. Alright, we'll have finished very damaged. And so we also have lubrication oil tank, which I mean, like personal, I rather use oil than coolant. Specifically, if I'm working with real material such as steel above the 2024, for example, that's a very, very hard material. And that's, therefore, I prefer using oil rather than the coolant. But I mean, it's up to each person, each up to each manufacturer, of course, and the rules are, I mean, like, are free to use in this case. Okay, and finally, we have something called the PLC, which stands for Programmable Logical Controller. So the machine, of course, like I said, is gonna work automatically. All right, you're gonna put up your program. The machine is gonna recognize the program. It's gonna say, okay, I know what are you seeking for? What do you want to achieve at the end? So I'm gonna do it. However, the machine needs to have that brain, and that's what PLC does. The Programmable Logical Controller is a program specifically designed to make any machine to work or to achieve a specific function. All right, you can find them in all the industries. If you have seen these robotic controllers and everything like that for mechatronics and all this kind of stuff, they all use the PLC program in this case. All right, and that's pretty much all that the CNC machine, how the CNC machine is comprised. So thank you very much for watching the video. I really hope you enjoy it. Remember, you can also watch the video as many times as you want. If there's something that wasn't clear, you can also send me a message. I'm leaving you here as well, wherever you can send me a text or anything, an email as well, wherever you prefer. However, just of course be a little patient because it's not like I don't have anything to do during the day. I'm still busy, but please contact me if you have any other things. If you would like to share anything new, I'll be glad to know it and of course to answer. Thanks so much for watching. Hope you enjoyed this video. I know it was very long, but we finally made it.